software package. So what is the advantage of the unstructured grid? One is a garden sprinkler effect caused by structured grid. So as you see, there is a, depends on the resolution of the spectral, directional spectral resolution. So this is a difference between the significant weight height between structure and unstructured grid. So as you see, there is a sort of the garden sprinkler. It's named the garden sprinkler effect. So the we think unstructured grid simulation results avoid this effect. Can avoid this effect. So as you already saw the spotter, what is spotter? So we, Mori Sensei's team deploy the buoys in summer, then continue the observation. Then this spotter transmit the location and wave statistics and the wave spectra through the satellite. So in 2021, 12 buoys are installed like this, and then this is a drifting track. Then we overlapped our wave hindcast in summer of 2021. Then these are locations of the spotter. So maybe soon typhoon is overpass here. And wait a second. I remember. Here's one typhoon, and here, this one is a biggest one in 2021. Okay, then this is, as Mori Sensei already shown, Adi-san picked up our spotter, then start from the, here, then drifted through the, along the Thailand and arrived at Indonesia finally. Then we received the significant wave height and mid-wave period during the drifting. Okay, so another second part of my presentation is the analysis of wave climate around Indonesia based on JRA 55 analysis. So our wave hindcast results, we estimate the extreme value. So this is a 30-year return period wave height around Indonesia, then Java and Bali. So as you can see, about 4 meter to 5 meter along the southern side, and northern side is 2 to 3 meters. So this is the same, but the return period is 50 years. So maybe lifetime of the concrete structures. So either we don't know exactly PUPL's regulation which you use, but you may use this result. Then this hindcast results can detect the event. So this is a top one significant wave height event. This is a top one significant wave height around Indonesia. Then we can detect when it occurs. So around the Java and Bali, we estimate the period July 2018 would be the cause of the top one event. Then we showed, this is a time series of that period from 21 to 25 July. So high wave occurred Southern Ocean, then travel to Indonesia. then maybe 25 July, highest wave attacked Indonesian coast. So there is a journal, Professor Shimozo in University of Tokyo. He did a survey report and intensifying swells and impacts on the south coast of Java, Indonesia. That period is same as our results. So, and also Shimura Sensei found YouTube. So here is a surfer. So, you know, how you can imagine how high is this swell attacks Uluwatu, Bali. Okay. So amazingly, this professor surfer continues surfing. Okay. Okay, that's all my presentation. Thank you very much.
Thank you very much, Yasuda Sensei. He's talking about the modeling with the watch wave and with the difference between the unstructured and structured grid. And then the second one is in Indonesia. There is a huge swell from the southern sea, right? From the southern direction. Okay. The next speaker is Professor Shigeru Kato. So Kato Sensei from Japan team. He's going to talk about the guideline for coastal beach monitoring. So this is our guideline. Kato Sensei, thank you.
Thank you very much. My name is Kato from Toyohashi University of Technology. So today, as he said, it is not guideline. It only the introduction of our coastal survey. So I'm sorry. So the title of the long-term monitoring and sandy beach coast cross-sectional profile on our Omotehama coast. It's facing the Pacific Ocean. Let's skip. Okay. So our summary of our survey is this survey was started from the 1999 May until now. And it means we continued this survey more than 20 years in our laboratory. And the frequency is once a week by the student. So the voluntary, our student tried conduct the field survey every week. That method is very simple. We use the leveling at the low tide because we want to measure as long as possible from the landmark benchmark to the shore water edge. Then the cross-shore profile, we measured. Sorry. Then from this leveling, so we measure the cross-shore profile from the benchmark. It means the land side reference location on the until the water edge. The shoreline position at the beach wheels is measured. It means by like this. And this leveling every 5 meters. And we define an intersection of the survey result and some reference level. This reference level, we use the high water level in Pacific Ocean near our Aichi prefecture. And also we measured the beach width, its beach distance from benchmark to water edge. It's beach distance. We say the shoreline distance. And this survey is conducted at the 4 locations near our university. Our university is very close to here, maybe about 10 or 15 minutes by car. So our student can go every week between some free time between the classroom. And we measured cross-shore profile at these 4 locations. This is the view of each location. Unfortunately, each beach has some blocks, but this coast is no block, but in the offshore, some detached breakwater is here. And then total number of our measurements is more than 1,000 because once a week, so it means more than 5 data in 1 year and multiply 20 years. So totally more than 1,000 years. But unfortunately, sometimes the student missed. So there are some error. And also, we measured by the leveling, using the leveling from benchmark to water edge. But sometimes this location is over the reference level. So at that time, we use extrapolation to calculate this intersection. At that time, maybe the accuracy of the location is not so good. Then we removed these extrapolation data. So totally, we have the available more than 800 data is available. But this cost is a little bit smaller than the other data because this cost has some coastal project. This is the coastal project site. So we start the coastal survey after the project. So these 3 locations is more than 20 years survey, but this is less than 20 years. And this is just example of our survey data. This is a cross-show profile of each year. This is the only example from the 2009. So we can capture these cross-show profile change in each year, and red line is the annual average, and these black lines are weekly profile. So each beach has a lot of change in every year. But some year very smooth, almost straight, but sometimes there are some berm. So we have to capture these characteristics of this beach. This is a color map of the cross-shore profile for all periods. So this black line indicates the shore position using our definition. And this is the whole coast. This is a coastal project site. So after here is a coastal project. So the trend is different. But anyway, from this figure, so we can find some annual, it means the seasonal change and the fluctuation of the beach coastal shoreline position is about 30 to 40 meters per year, every year. But sometimes the big change is occurred. But this big change also recovered within the 1 year. Because like this, it's a seasonal change in decrease. This side is a retreat, and this is the side to the ocean. So it is the advance and the retreat. So every year, like this fluctuation, it's a seasonal fluctuation. And maximally about 40 meters is changed in every year. And we can find that these several years fluctuation, period is several years. We can find these fluctuations. And from these data, we find the long-term trend of the shoreline position. So red line is the linear regression line of the whole period. So all of data, this data is a little strange because we don't have the coastal project. So maybe a little decrease, but other 3 coasts, almost Kojima, this coast is almost stable along the 20 years. But this beach and this beach is slightly advanced. Now also, this is the relationship between the sea condition. Sea condition means that typhoon in Japan. This yellow line is the event of the typhoon. So almost year that we have typhoon approaches this Omotoyama coast. and shoreline position retreat greatly with the typhoon. This yellow line is a typhoon. So from when we have the typhoon, the shoreline position retreat very big. But after that, maybe recovered. But after the typhoon, retreat again, recover, and retreat, recover, and retreat, recover, like this. So, however, shoreline position really remained receding for long period. So suddenly decrease, but many of them can recover within the 1 year and within the signal change. So when the decrease does not recover, when the large decrease cannot recover, that's the coastal erosion is occurred in the coast. But fortunately, in our coast, we did not find this big erosion in this coast. So summary of our coastal survey in the Oktariyanto coast. So shoreline change is the tendency is almost stable and slightly advanced over the last 20 years. Quite, but repeating seasonal change every year. However, compared to the change in the first, I skipped this result, so I'll skip here. And the fluctuation range of the shoreline position about 30 to 40 meters every year. It's very big change, but due to the typhoon, it means a high wave condition change of the more than 20 meters. It means only 1 day or 1 or 2 days. The 20-meter shoreline retreat have occurred in the very, very short time within the 1 week. It means the period of the typhoon event. And the rapid shoreline retreat occurred in such a short period. However, shoreline position will remain receding for a long time of period. Most of them recovered in the signal within the seasonal change. So I think I recommend it is a recommendation and my problem. The question for the long shoreline monitoring is long-term and continuous measurement is very important. It is essential for the monitoring to know the shoreline characteristic. And the measurement error, unfortunately, our case, the student do. So sometimes the student miss. So better to know the accurate characteristic of the shoreline change, the error is error must be avoided. And my question is how we can define the shoreline position, because water edge change from motion to motion. So what is the shoreline? There are many papers about the shoreline change, but the definition is different in each paper. So in your survey, how would you define the shoreline position in the survey? The cross-shore profile from the beach to closure depth is important. Our data is on the beach because students do. So it is impossible to measure under the water for the but data in or under the water is indispensable to investigate the mechanism of the beach change, because beach profile is continue from the on land to under the water. And also survey frequency is also sometimes important. And the frequent survey is desirable. Or for example, it's every day, it's best. But I think it is impossible. So how often we can measure? But maybe it is depend on the purpose of this monitoring. For our case, we want to know the response for the typhoon, maybe less than 1 week is necessary. But if you want to know the seasonal change, maybe once a month or every season, in our case, season is a 4 seasons, so every 3 months or every 4 months. But in your case, it's season 2. But 2 in 1 year, it's very difficult to know the characteristic of the shoreline change. So firstly, we have to fix the purpose of the monitoring. And we have to determine the survey frequency to catch that to achieve our purpose. Thank you very much for my presentation.
Thank you very much, Kato. Which is very difficult. It's expensive and labor intensive, correct? But Kato Sensei, I think you are lucky you have a student to do it for you. All right, and there are 2 points then we need to take note, I think. The first one is, what is the definition of coastline? So we are not really definite yet of what the definition of coastline. Maybe we need to discuss more and just use one definition probably. And then the second one is that how frequent we have to do the experiment, the measurement. Is it a weekly enough, or monthly, or something like that? So there are 2 points that we need to take into our attention. I think it's that the topic that Kato Sensei gave us today. So now we reach our last, but of course not least, topic is the river risk modeling from Dr. Eva Yamamoto. And this talk will be given by Mori Sensei. So this topic may be the interest of Balai Sungai. Thank you. The floor is yours, Dr. Mori. Professor Mori.
Thank you very much. I'm talking about recent progress of our hydrological simulation targeting especially Denpasar area using rainfall runoff model. And this result is evaluated by the Dr. Eva Yamamoto, Eva Miska Yamamoto. Actually, she's originally Indonesian, living in Bali, but now she's an assistant professor in DPRI of Kyoto University, working with us now. So this is a kind of interim first report of the progress from her. So she made 3 different simulations of the river flooding from 500 resolution to the 30-meter resolution. So I'm going to briefly show you results today. So this is a 500-meter resolution simulation entire Bali Island. So of course, 500-meter spatial resolution is not enough, but it's okay to understand the entire whole behavior of the hydrology process of the Bali. So color means a different level of the water discharge. And we found the big problem was the validation, because hydrology model required the validation of the soil and other parameters. And the bottom line indicate river flowing, blue line indicates simulation, and the red line indicates observed gauge data set at Unda River. And obviously, observation, red one is something wrong, because baseline is changed in upward or downward, depends on the phase. So we confused about this result. So we realized importance of the water level or water flowing measurement must be necessary to calibrate of our model in detail in here. So, and then we move to the more higher resolution model using higher topography data set. So 90 resolution model uses Merit DEM developed by Dr. Yamazaki at University of Tokyo. And we also incorporate with JAXA 30-meter resolution DSM at the same time. And then high resolution model required more computation time. So we just focus on Denpasar area for computation. So there are 3 major rivers in this area, Meti, Badun, and Rowan. These are probably important for the Denpasar area. And then we try to update cross-section or detail of the river profile, topography profile, but we are still something missing yet. And for example, this is a Badun main river channel, and it has a kind of irregular shape of this. And we also found some differences of the base riverbed elevation between the model to the observation. But anyway, first we hindcast historical recent flood occurred in October 8th of 2022. And there are several reports of the flooding along the middle of the Denpasar area. Then this is the simulated results of the maximum water level on the ground as well as the river. And then we found there are underestimation of the model, simulated model, because there are 5 stars around here where inundation were reported by the public, but some model cannot capture some area. And additionally, underestimation was also found in Sanur area because there was no flooding in the model. So we have to update the model to capture these underestimation. Then additionally, we made a more extreme simulation, assuming 20 years return period rainfall. It's arbitrary, but we just assume 20 years return period rainfall must be a kind of design for making risk map. Then, based on the historical rainfall data set, we estimate 20 years return period rainfall, which correspond to the 250 millimeter per day. And then this is obtained risk map of the river flooding with 90-meter resolution model. And obviously, there's so many flooding occurred around here, so it must be something wrong. And this area is too much flooding. Historically, there was no flood in this area, but we found too much flooding in this area by the model. So model has something wrong to be improved. So one is a river modification because we didn't include river embankment along some part of the river. So we updated the model. We have to update local information, and 30-meter resolution model is also still underestimated. So we have to update some part of the river, cross-section river. But anyway, this is a kind of first trial to estimate 20 years return period risk map of the Denpasar area. And one curious thing is we found a kind of high risk area near the river mouth, which must be important to cooperate with a coastal flooding team. And left panel indicate the current risk map obtained by somewhere. I forgot to ask to Eva-san, but this is a current risk map. This is slightly similar to our 90-meter resolution model, but it must be too much flooding in current risk map. So we may improve more realistic flood map using RR model, updating local information. So this is the last slide from Eva-san today. So it is possible to obtain more detail of the cross-sectional river dataset from PU, BWS, or JICA. And second question is, do you have recent flood inundation recorded map? And the third one is not question. AW3D DSM 30-meter, which is JAXA, Japanese NASA made new type of the DSM data, and which is better than other course resolution model. But she asked me money to improve. And the last one is there any Indonesian agencies to share the more high resolution precipitation data set in Bali? Because now we are using very coarse resolution of the rainfall, but we need a more high resolution precipitation data set. So it must be good to discuss. So to summarize, we need a more detail of the cross-sectional data and the historical flooding data and rainfall data. This is my asked message from Eva-san to here. Terima kasih.
Thank you, Mori Sensei. So we still need data. Okay, maybe the people from the Balai Wilayah Sungai would give the data to Professor Mori. Okay, we finished with the speaker and the talk, but right now we open for two questions. First, any question? Oh, Udin.
Thank you, Bu Entin. My question for Kato Sensei. How do you define or how do you determine the benchmark of the coastal landslide? So, how do you determine the benchmark? Because the benchmark of the coastal landslide, right? So you measure the beach profile from the benchmark into the water edge, right? So how do you define the benchmark? How do you determine? Okay.
Oh, mic on.
We need the fixed point. So we found there are the blocks or some road or concrete block, and then we set our benchmark. So each coast, and then we measure very accurate the position, the first, and every time we start from the benchmark to water edge. Yes. So sometimes we transform some location to in the coordinate system, but we only use the local coordinate, only distance. So the accurate the benchmark is the origin of the axis, but this has the very accurate height, and then we measured every 5 meters. So x direction is +5, +5, +5, but elevation is measured by the leveling. So benchmark is our original benchmark for the fixed point. Yes, but unfortunately in the coastal side it changed, so we measured again. Then the trend is a little different. We try to find the very close point, but unfortunately at that time the coastal side removed our benchmark block. Then we found a very close point. So, but a little bit difference. Thank you very much.
Next question.
Thank you, Dr. Entin. I want to ask to Kato Sensei, you said that the measurement of the beach profile should be until the depth closer. If in front of the coastline there's a reef flat, so can we assume the reef flat as the closer depth, or should we measure the beach profile until we pass the reef flat and we find the closer depth? Thank you.
まあ、限界水深まで計測するあるのか。必要あるのか。
In case of on the shoreline position, maybe the closure depth is not important. But if we want to know the mechanism of the beach profile change, we have to know the on land and under the water, because sediment will be exchanged on the land and under the water. And sometimes on the beach, there are very erosion, but this sand moved only a little bit far from the shoreline position. At that time, maybe this erosion can recover. But if there are big erosion and these move far away, maybe this erosion is very critical. So we have to consider some countermeasure for this erosion. So to know the mechanism of the beach profile change, I think the profile from land to under the water is very important. But only monitor the shoreline position, it is not necessary. So what is the purpose? Depend on the purpose of the coastal survey, I think.
Additionally, it is also important for the depending on the shape type of the beach. For along shore sediment transport dominant beach, maybe limit depth is not so really important because sediment transfer along the beach. But for cross-sectional sediment dominant beach, bar movement is very important. So we have to measure to the end of the closure depths.
Was this more questions probably?
Yeah.
Dr.
Oh, maybe there's.
Dr. Arte?
No, I just the issue that Professor Mori mentioned in the last presentation. Maybe I would like to invite the representative from BWS Bali Penida. Maybe do you have some comment or information about the issue, about the data of and the surrounding of the Bali River?
Yeah, asking Indonesia is okay.
Mungkin bisa minta tolong disampaikan kondisi datanya. This one, the last. Yeah, this one.
Yeah.
Mungkin maaf nih dalam bahasa Indonesia. Mungkin karena besok kan ada rencana ke BWS ya. Mungkin bisa besok aja diskusi lebih lanjut di BWS.
So tomorrow they will explain about
Okay.
Please wait.
Yes, sorry, Pak Adi.
Okay.
Yeah, Mori Sensei. Maybe tomorrow we will go to Bali Penida River Basin Organization. So I think your presentation based on Eva Sensei work is very important for Balai Wilayah Sungai Penida. So maybe we would like to ask you to make presentation again tomorrow with the same materials.
Yeah, terima kasih. I can make it better tomorrow. And additionally, combining Yasuda Sensei's talk for the 40 years high-resolution wave climate simulation, including this river hydrology simulation, we are very happy to provide any data and any source code to the Indonesian collaborators. So we can, provide both data and the source code together. And it is also welcome to invite young researchers to Japan to understand data set or simulation. We can discuss anytime. Terima kasih.
Pak RK. One question from Pak RK. Last question probably Pak Adi. Okay.
Not question, just continuing the discussion, a previous discussion before with Kato Sensei. In our project, we use the camera. And do you think we can understand also the mechanism of what you are saying by using the camera instead of conducting the direct measurement? What is the lag from this SATREPS technique by using the camera? Perhaps we can overcome the lack of using camera with some other technique. I don't know, but yeah.
So it means it is impossible to measure the crucial profile in your research. Yes. So the purpose of this your monitoring is maybe firstly to capture the characteristics of the beach shoreline change. So firstly, the web camera is very useful for this purpose. But there are some big change or the coastal profile or also the beach erosion. So maybe you need additional survey for including under the water because as says Professor Mori, so we have to know the characteristics of the beach profile change. It means along shore sediment or crucial sediment, which is the dominant, and also what is the how change and what is the impact of the beach shoreline change. So at that time, maybe we have to reorganize these survey, purpose of these survey, and then, or maybe do you put the additional survey for the, yes, I think so.
Right, thank you. So we are in the end of our workshop now. So thank you so much for all the speakers today. And thank you everybody for coming. And hopefully this is all very useful for us, that our discussion. And maybe next is we could look at the equipment. Is that it, Pak Adi? Okay, before we finish, one more applause, round of applause for the speakers. Thank you.
Yeah, thank you very much, Bu Entin. So, yeah, it is very fruitful workshop and meaningful discussion. So I'd like to express my thanks to all speakers from Indonesian teams, Dr. Farid, Dr. Bagus, Dr. Eka, Dr. Tubagus, and also from the Japanese team, Professor Mori, Professor Yasuda, Professor Kato, and especially for Dr. Entin, who has moderated this workshop. And to everyone, thank you very much for your actively participation and share your insights during our discussion. And also, yeah, this is a good news from the Professor Mori that's mentioned before. So they will give us 40 years data set.
Provide.
Yeah, provide. Yes, provide the 40 years web observation data. So it's very important data for calibrating our numerical model. So please, explain. Okay, thank you very much and see you in next workshop in Japan. Thank you. Selamat siang. Okay. Oh, yeah. Maybe kita foto bersama dulu. Kita foto bersama dulu ya.
Maybe before we move outside, so maybe we can take photo first.